microwave speaks a lot of you. Wait, guys.
What are you doing here?
We're not exactly sure where here is. Our ship crashed a few yards back. We're not. Do you have any resources we could use?
Yeah, sure. Let's just go back to my place.
Once again, thank you for letting us use your base and for giving us these extra clothing.
No problem.
So, do you have a lab we could use?
Yeah.
Does it have a comm system?
Well, the communication system is right here.
Do we really have to cut my hair though?
Yes.
Alright, you guys work with the comm system, alright? Could you show me the lab?
Yeah, sure. Follow me.
Alright.
Time to get my work on. Alright, so getting this concept to work should be pretty simple. We were at Earth, right? No. Yeah, we were at Earth. Okay, so let's take Earth. Alright. And this should pull up the video now.
Finally. What happened to you guys?
We kind of ran out of fuel.
That's very bad. You guys need to find more fuel and get home now.
Copy that.
So we need to go tell Kayla that we got connection going on. Quick, come on. We need to go. Hey, Kayla! Control said we need to get rocket fuel to fill up our ship.
Really? Do you have any rocket fuel we could use?
No, but we can make some using stoichiometry.
Oh wait, what's stoichiometry?
Stoichiometry is the relationship between the relative quantities of substances taking part in a reaction or forming a compound, typically a ratio of whole integers.
Huh.
We could also use a balance equation with our stoichiometry.
What's the balance equation?
A balance equation is the need for a chemical equation to follow the law of conservation of mass. We have to have the number of reactants we use and products equal to each other.
Oh, okay. But wait, so how are we supposed to figure out the elements?
Well, we can use a periodic table for that.
What's a periodic table?
Periodic table is a table of elements used by chemists to figure out problems just like the one that we're in right now.
Can you show an example?
Yeah, sure. Okay, so here we have a combustion reaction that is unbalanced. So first, we would balance out the carbons. There are 2 carbons on the left side and only 1 carbon on the right. So you would put a 2 here, and now the carbons are balanced. So now let's balance out the hydrogen. There's 6 hydrogens on the left and only 1 hydrogen on the right. So to balance this out, you would put a 3. So now there's 6 here and 6 here. Next comes the oxygen. There's 7 in total. So that would mean it'd be 3.5 to make 7. But we can't have 3.5. So you would multiply it by 2, and that would equal 7. So now let's rewrite this. 2C2H6 plus 7O2 yields 4CO2 plus 6H2O. And now you have a balanced equation.
So, now that we have our balanced equation, we can solve this simple chemistry problem. How many grams of CO2 could be made from 100.0 grams of O2? Well, this problem is pretty simple. We're going from grams to moles, back to moles, and going to grams. This is the flow of our math right now. So we start off with 100.0 grams of O2, and we'll convert that to moles by using the simple conversions, which is 1 mole of O2, which if you look on the actual periodic table, O2 is 16.00 AMU. So if you take 16.02 times 2 on the calculator, 16.00 times 2 equals 13. And we already have to keep the decimals, so 32.00 G's of O2, which will give us, if we go on a calculator, 100 divided by 32.00 equals 3.125 moles of O2. Right? Now, if we take these moles and we need to use the ratio of O2 and CO2 in the equation. As you can see up here, we need 7 O2s to make 4 CO2s. So we're going to CO2. So we need to have CO2 on the top of the ratio and O2 at the bottom of the ratio. So 4 moles of CO2 over 7 moles of O2. As you can see here, we can balance out our moles of O2 by using the simple ratio. So if we cross out these with these, you can see that we're left with moles of CO2. So now we take 3.125 times 4, which equals this, and then we divide it by 7, will give us 1.785, well, 6 actually, if you round it, moles of CO2. And from here, we do the same thing we did with oxygen. We need to convert it to grams. We're just doing it backwards. So to do it backwards, we need to figure out how much CO2 weighs. So if you go on the periodic table again, we know that O2 is 32 AMU. So now we just have to add 12.01 to that. So if you go to the calculator, 12.01 plus 32 equals 44.01. Right? So that's our AMU of carbon dioxide. So here, grams of CO2 over 1 mole of CO2. And this, now we do our math, which is 1.786 times 44.01 equals a total of 78.60 grams of CO2.
Good job, team. Now, what did we learn today?
Well, we learned that stoichiometry is a relation between the quantities of substances that take part in a reaction to form a compound.
We also learned that a balanced chemical equation occurs when the number of the different atoms of elements in the reaction side is equal to that of the product side.
We also learned that temperature can greatly affect your equation.
We also learned that what a periodic table is. Ow! God damn.